Here. So when the last index is less than array size minus 1, that means the array heap is not full, so you can further insert the new node. Then it will ask to insert the new node from the user. So it will ask a number which will be inserted into that heap. So enter value to be inserted. Enter value to be inserted. So to insert to a certain variable need to be declared. Suppose int num. That would be used to enter a value from the user. So I am using a scanf function here to enter the value, which is scanf %t and %num. So once this num has been entered by the user, we will assign which position to the array. Now at the last index position of the array, this num will be first placed there. So array, how to find out the last index position? Because already that is stored in that into that location, that last index variable, it is stored. So last index equals to array last index equals to num. Then what we have to do? We have inserted the new node at the bottommost position of the tree. Now we have to place it proper position into the tree so that it satisfies the heap. That means it will be placed as its proper position so that the node under the children of this node num will have less value than it, and total tree will be also a heap. So we have to do that. That means this number, new value, to be checked for the upward movement. If it is less greater than its parent, then that new value will be moved upwards. Then again, from that position, it will be moved upward if its parent is less than it, and it will go after until we are going to the root position. This will go on, but that is the condition of stopping of upward movement. Or another condition is that when it is at particular position, its parent is already greater than it, than the child. Then no movement will be considered. So that are the two stopping conditions. Either the parent is greater than the child, or parent is less than the child, and they are interchanging their position. And this is going on until we reach to the root position. So for that, what we will do? Now we will do the position of movement, upward movements is required. So for that, we are using a function move up. And here only the last index value will be passed where the new node is currently inserted. So that is stored in last index variable. So that is and now after that, the insertion operation move up before movement. What was the position of it that I want to print? So print it. Here I am printing. The printing array, printing heap before printing heap. Printing heap before printing heap, and the function will be called print array, which will print the array. And when the movement is over, then again I will print into the array. So here, after movement, upward movement, we are printing heap after insertion, insertion of percentage t dot percentage t dot hence none after insertion of not this not percentage t. Now we have to write the move up this function. So we will go to upper position and first we will declare the void move up, void move up, and here I am using the passing the current position of the new node, and we are declaring the function now void move up, defining the function body int index. So if suppose if it is already in the current new node is already at the root position, in that case we cannot do further upward movement. So if the index position is greater than 1, that means new node is not at the root node position, but the root node is at index 1 position, which is greater. That means when the index value is greater than 1, then only upward movements to be considered. Otherwise, it is already in the root node position. If it is index equals 1, then how can I move further? Well, because that is the highest and the highest, that is the root node, index 1 node. So here I have to check that if index is greater than 1, then only we will check for the upward movement. So here, one thing I need to do for this upward movement, I have to find out the parent. Okay, parent variable of it. If index is greater than 1, then parent equals to index by 2. For upward movement, we are going to the upper position. That means we are going to the parent position, which can be found by dividing the child index by 2. Okay. Now it will check if array parent is less than array index, then the swapping will be done. For swapping, we need another variable which will be 10 equals to. So what if array parent is less than array index? So initially 10 will be assigned the value of parent. Then child value, as it is greater than its parent, will go to the array parent position. That is array parent equals to array index. Okay, index. Next, array index position, there will find the parent value that is stored in 10. So 10 will be assigned to array index. Next, we will again call the move up function for this parent position, because now this parent will be checked with its parent again. So I will call the move up function here, but here index, which will be checked for swapping with for upward movement. In that case, the index value is now as parent. So that is the move up parent operation. And if array parent, this condition that array parent is not less than array index, then there is no point of swapping. That means there is no point of upward movements. When that is, we will do nothing. So this is the move up function. So before move up function, the position it will not be him, but after move up function, the total array elements, including the new node, will be converted into a heap. So that is the function. Now, what I will do, I will here I will go to main function of the. Here in main function, I will do the insertion operation. If I want to do the insertion operation, then that choice will be inserted by the user whether I want to insert further or not. If I want to insert further, then there will be the function insert will be called again the number which I want to insert that will be entered by the user. That will be done. So this part will be written in the next part. So